Okay, we're going to continue our conversation with proportional relationship. Except today we're going to bump it up and talk about directly proportional relationships. A directly proportional relationship is defined as y is directly proportional with x. Now when I say directly proportional, what I mean is I can get directly to y if I multiply x by something. So I can multiply x by something to get to my y. For example, if I was given this table, 1, 2, 3, 5, 10, 15. This represents a directly proportional relationship because I can times x by 5 to get to y. 1 times 5, I get directly to y. 2 times 5, I get directly to y. 3 times 5, I get directly to y. This equation is y equals 5x. It is directly proportional. I can multiply x by something to get to y. Make a little cloud around this formula. This is what a directly proportional relationship formula looks like. Y equals something x. This something is what we multiply x by to get to the y. So notice here I multiplied x by 5. So that's what went there, that 5 went there. It's called our constant of variation. The constant of variation is represented as a ratio y over x. It's similar to slope, where slope is change in y over change in x. But for directly proportional, we just don't do the change part. It's just a ratio of y over x. And it's really whatever is in front of the x in the equation. I want to touch base with this ratio, and I want to look at the little table I made you. I told you that a directly proportional relationship is a constant ratio of y over x. And I want to show you that this represents a directly proportional relationship because I can multiply x by something to get to y. But sometimes you can't think that fast. And if you think about the relationship y over x, 5 over 1, 10 over 2, y over x, 15 over 3, are they all the same thing?
Yes.
5,
Yes.
5, 5. That is your constant of variation. So today I'm going to ask you to find constant of variation, and it's not going to be as quick mental math. You're going to have to think about, okay, according to the definition on the front page, it is whatever the ratio y over x is. Okay? And proportional is the equality of two ratios. I'm not sure why I put that there, but whatever. We'll roll with it. Okay. So here's some properties of directly, I forgot that, directly proportional relationships. Remember, you directly get to y. You multiply x by something and you directly will get to the y. The biggest learning target that you need to know is it will always go through the origin on a graph. Because if it's y equals something times x, well, if x is 0 and you put a 0 in there, according to the 0 property, 0 times anything will be 0. So that's the definition of directly proportional. That means that if x is ever 0, then y has to be 0. The other thing is there's only x and y terms. For example, 5y equals 3x. That's directly proportional. I have y terms and x terms. I don't care that there's a 5 and a 3. It's sticking to the variable. This is a non-example. No, would be 5y equals 3x plus 1. That's not right because this 1 made it not true. I have my y, I have my x, and then I have this 1. That's not direct. Some examples. Scooting, just make a whole bunch of lines. As long as they go through the origin, it is directly proportional. Look at this beautiful snowflake I'm making. Aw, man. Oh, well. All right. So just a bunch of lines that go through the origin. The learning target there, that you know directly proportional relationships will always go through the origin. Always. Go through the origin. Okay? So there we go. 5.5 minutes on the front page. Moving on to the second page. Hey, we just talked about this. Proportional relationships go through the origin. That means 0, 0 if you don't know that vocabulary. That also means the center. It's the intersecting point of two axes. So it's a level 2 type question. If you say, hey, is this directly proportional or no? All you're checking, does it go through the origin? Does this go through the origin? No. So that's a big no, because it does not go through the origin. What about the second one? Does this go through the origin? Yes. Sure does. Yep. This is directly proportional. I don't have to do a lot of math for this. I just identify. Does this one go through the origin? No. No. Okay, no. Got it. And the last one is the last one directly proportional? Yep. Yep. Okay. Got it. All right, so that's how you identify it when you're given a graph. If you're given a graph, you just check to see, does it go through the origin? If it goes through the origin, it is directly proportional. Sometimes you have to identify it from a table. According to directly proportional, we want to check to see if a ratio of y over x is constant. It's the constant of variation. Is y over x constantly the same thing? Quickest way though, see if you can multiply x by something to get to y. That's of course the quickest way, but trust that it's not always quick. Okay? If it's quick, you embrace it and let it be quick, but it's not always quick. If you can't tell, if you can multiply x by something to get to y, you have to check the ratio. Check the ratio of y to x. Y over x. Not change in y, not slope, just one ratio, y over x. Okay, so let's analyze this first table. I want to know, is this directly proportional or not? So I want to know, can I multiply x by something to get to y? Can I multiply 10 by something to get to 4? No. Okay, so my brain says no, but I'm not going to trust. There's another thing I can check. I'm going to see if my ratio of y to x is the same throughout. So y to x, that's always what I'm checking, y over x. 0 over 0, can't analyze that. 4 over 10, 8 over 20, 12 over 30, y over x. Are they the same? 2/5. What's that? 2/5. What's this? 2/5. Yes, this is directly proportional. And you want to know how to make an equation? I'll show you. The constant of variation is that ratio y over x. So I can create an equation, and my equation would be y equals 2/5 x. And you want me to prove it to you, kind of? Yeah, huh? 2, okay, so watch. 2 divided by 5 is 0.4. So I'm going to tell you that if I multiply x by 0.4, I'll get to my y's. 10 times 0.4 is 4. 20 times 0.4 is 8. 30 times 0.4, what do you know? It's 12. You sure can. But at first, we didn't think you could, did we? We said, nope, can't do it. Because in our heads, we couldn't think, what do you times 10 by to get? You didn't think, oh, clearly you times it by 0.4. You don't think that, okay, and right away. Okay, let's check another one. I always check nice and the easier one first. Can I multiply x by something to get to y? You only do the ratio if you can't think of what you multiply by. Can I multiply 4 by something to get to negative 24?
Yes.
Yeah, negative 6. Let me check. 5 times negative 6, yep. 9 times negative 6, yep. So that means that is my constant of variation. So it is going to be negative 6x. But hey, I just want to also show you that the ratio is also the same. Maybe you just only want to use ratios because you're used to y over x now. Maybe you just want to go negative 24 over 4, negative 30 over 5, negative 54 over 9. Hey, look, they're all negative 6. It's all the same.
What?
And you want to know what the constant of variation is? Whatever is in front of your x is your constant of variation. Okay? And so, what we've done so far, we've defined directly proportional relationships. We've identified directly proportional relationships given a graph. We checked to see if it went through the origin. Now we identify directly proportional relationships with a table. We check the ratio y over x. The last thing that we're going to do on this video is identify directly proportional and not directly proportional given an equation. So again, directly, write directly. I kept forgetting to do that. Directly. That means there's only x and y's. There should only be x terms and y terms. That's it. Okay? So, looking at this first example I have here, 6y equals negative 3x. Are there only x and y terms? Yes, 6y, negative 3x. Yep, because they're sticking to it. They're all one. They're a unit. So that is directly proportional. 4y minus 3 equals 8x is not directly proportional because I have this minus 3. That's what made it not directly proportional. Okay? I should only have x terms and y terms. Notice at first the 6y, it's still one thing. What about this? 9x plus 3y equals negative 1. Yes or no?
No.
And what makes it no? The negative 1 made it no. Yep. Whoopsies. So this is, hey, this is not directly proportional because of that negative 1. What about 0 minus 7y equals 4x? Yes! Because the 0 can just be forgotten about. So then I have a negative 7y and a 4x. So that's only x and y stuff. 5x equals 6y. Yes or no? Yes. Only x and y. 3x minus 2y equals 4. Yes or no? Why? The 4 made it not directly proportional.